Now let's see how we could create a text index for a bunch of documents, such as the 3 documents we had earlier. We go through each document one by one, reading each word in turn. When we read the word the, we insert an element against the in the final structure that we want to create. Similarly, we read the word quick, we enter a.com as the ID of this document against quick. Similarly for brown, similarly for over, and for other words in this document. Moving on to the next document, we do the same thing. Enter bird with b.com this time instead of a.com, because now we're processing the second document. Similarly for the third document, but this time, since the is already present in the index, we merely append the entry c.com after a.com against the, rather than create a new entry. Similarly for lazy, bird, and finally for worm we enter a new entry with just c.com against it. How would we write a program to do this? Now we'll go a little bit slowly while describing this program, because I'm not assuming everybody is familiar with programming in Python or object-oriented programming, or even if you are, I'm assuming that you need a bit of refreshment. So we'll create a class index, which is going to be the data structure index that we're going to create, which will have a function which will create, which given a list of documents D, this function will essentially populate our index in this manner. So what we'll do is we'll go through each document in D. Now in Python what this means is that if D is a list, for D in D will essentially iterate over each document in D one by one, and for each such document small d we'll go through each word W in that document. Once again we're assuming the document small d in this list of documents D is itself a list of words this time. So for each of these words we'll go through the document small d, and here we'll call another function, lookup, also on the same data structure index that we are creating, and lookup will check if this word W is already in the index. Moreover, if the word W is in the index, then we assume that the lookup function will return I, which will give us the position in the list where W actually is present, so that we can access W directly. For example, if we're looking at the word quick, then it will return I equal to 0, 1, 2, 3, 4, 5, 6, so that we can directly access this particular part of the index structure. If W is not in the index structure, then we assume that this function lookup returns a negative number. If that is the case, then we have to add W to the index afresh, just like we added worm in the end. And in that case, the function add, which does this, will return the position where W was added. So for example, here it would return the position 8. Once we have that position 8, we can append to this list against worm, for example, the ID of the document where the word W was found, which is d.id. Notice that we don't append D directly, because D itself is a list of words. So we don't want to append the entire document here. We want to append only the name of that document, or the ID, or the web page, or URL of that document. Going back, there's an else part, of course. If we did find W in the first place, we would simply append the ID at that position I without having to add a fresh entry into the index. So that's simple. So this program, if we're able to write all these functions, lookup, add, append, then we can essentially go through this list of documents where each document is a list of words and create this index structure fairly simply. We'll probably do some such assignment later on in the course, but at that time we'll do it on many machines using parallel computing, the way it's actually done in Google and other large search engines.